All right, this is a video where I teach one of my favorite math topics. This is definitely not for middle school. This is a high school topic that I learned in Precalculus. So we're going to learn about the unit circle. So a unit circle, when I say the word unit, in middle school you probably do recognize the word unit. When I say unit rate or unit, what is your unit, what is your label? That's something that involves the number 1. So we have a circle with a radius of 1. Now what we're going to do is we're going to break this into 45-degree angles. So we'll go through from there to there. Got one from here to here, here to here, and here to here. Now, so that's 45 degrees. We're also going to break it into 30s. So let's see, it'd be from here to here, 30. Here's 60. Straight up would be 90. Another 30 takes us to here. So that'd be 120. Our 150 will be right here, 180. And we'll keep on going. Multiples of 30, multiples of 30. So I had a student who asked me about this topic. I mentioned it, and the student was really interested in it, so I'm making a video about it. So the radius of this circle from the center of our circle to any outside part of this circle, so from the center to the outside, is a length of 1. So our radius is 1 unit. That's why we've got a unit circle. So the radius of this circle is 1, and we can use this circle, and notice it's a coordinate plane where we have an x and a y axis, and we measured. There's a half, there's 1, there's a half, there's 1, there's negative a half, negative 1, negative a half, negative 1. And you've probably seen on your calculator these buttons, sine, cosine, and that's not an n, and tangent. So sine, cosine, and tangent. What the sine does is it measures vertical height of our point. So if I say right here is a point, the vertical height of that is a half, because it's 1/2 tall. So cosine then measures from left to right. So it would be somewhere around here. That would be our cosine value. It would be a positive number. And the tangent is whatever you get for your sine divided by your cosine. So let's go around the circle. Let's knock some of these out. Let's do this first one. The first one's going to be at 0 degrees. Okay. Now, this is also, so this is in degrees. You've also probably seen on your calculator a thing that says degree, rad. I think there's another one. Let me see. Degrees, radians, maybe polar, maybe POL, or parametric, PAR. So another way we can look at numbers is by radians. So 1 radian, or one pi radian, is from 0 to 180. So this would be known as pi. Halfway around a circle is pi. It's also 180 degrees. Those are 2 ways that we can write 180, which means 0 degrees is also 0 pi, so it's also a 0. If we go all the way around the circle, well, that's 360. It's equivalent to 0 because we went a full circle, because it's going to repeat itself depending on how many times you go around. And then it's also known as 2 pi. So in between 0 and pi, up here on the top, we're going to have pi divided by 2, pi over 2. So this is 1/2 pi. There's a 1 in front of this pi. 1/2 pi. This over here on the bottom will be 3 halves pi, or 1.5 pi's. So this is pi over 2. This is half. Well, over here is going to be pi over 4. So there's pi over 4. Here's 2 pi over 4. 2/4 pi is the same thing as 1/2. So this is 3/4 pi. So 3 pi over 4. Here's 4/4 with a pi. That simplifies to 1. This will be 5/4 pi. Here's 6/4 simplifies to 3 over 2. Here's 7/4. That's simplest form. And we have 8/4, which will be 2 pi. We do the same thing with our 30 degrees. Notice that from 0 to pi, we're broken into sixths. So this is 1/6 pi. Here's 2/6, which is simplified to 1/3. 3/6 is 1/3 or 1/2. Here's 4/6, which is simplified to 2/3. And if you notice, this is 1/3. Here's 2/3. Here's 3/3. So this one's going to be 5/6, 6/6, 7/6. 8/6 is simplified to 4/3. 9/6, 10/6 will be 5/3 simplified. 11/6, whoops, 11 pi over 6 is here. And then 12 pi over 6. 12 over 6, again, is equal to 2. So that'll bring us to 2 pi. It repeats it, and we get all the same stuff. In fact, let me get rid of that. I don't want it. And I'm also going to get rid of this because I need some work room here. So we're going to do some sine, cosine, and tangent of some of these spots. In fact, let me actually go around and give you some degree measurements too. So we've got, this is 30 degrees. This is 45 degrees, 60 degrees. This will be 90 degrees. Because we can do this in radians and in degrees. We're going to get the same answer depending on which type we think about. And if we were to use a calculator, you just would have to make sure you're in the right mode. So this one would be, so 90, 120. This will be 135, 120. This is 150 degrees. Here's 180. We're going to add 30 to that. Takes us to 210, 21, 24, 27. Nope, I missed one, didn't I? 180 plus 30. Oh, I skipped one. So this is 240. This is 27, 270, 300, 330, and 360. So I'm just counting by threes at this point. I noticed this one was wrong. So 180 plus 45 takes us to 225. So there we go, 225 degrees here in the middle. 300, so this will be 315. So there we have it all in degrees. So we have 0 degrees to 180 degrees. And there we have it. Now, we're going to learn about sine, cosine, and tangent. So when I say the word sine, that means how tall our line is. So if we'd say, I'm going to actually get rid of these two. Let's say we're going to do 0 degrees. So let's say sine, cosine, tangent of 0 degrees. Let's do 0, 90, 180, and 270. So 0, 90, 180, 270. And we could do 360 again, but it's going to be the same thing as what we have for 0. So our question here is, let's see, sine of 0. How tall is it right here at this specific green point? How tall is it? Well, it's 0 tall. Its vertical height, its height on the y-axis, its coordinate is 1, 0. So its sine is the y value is 0. Its cosine is the x value, and this will be 1. So this is the y value. This is the x value. And tangent is y over x. So 0 divided by 1 is 0. And if you grab a calculator and you do these sine buttons, sine of 0, we get 0. So that's where those numbers come from. That's what these buttons on this calculator mean. Let's do 90. Sine is 1. cosine is 0. 1 divided by 0, you can't do it. You can't divide by 0. You can't tell me how many zeros are in the number 1. 180, sine, careful, we are, we're still 0. For cosine, because this point right here is at 0, but our cosine is -1. So 0 divided by -1, well, we're still 0 for our tangent. And then for 270, we've got sine is -1, cosine is 0, the x value is 0, and we have -1 divided by 0. You can't do it. Undefined. Doesn't work. I can show you why at another time. But what we have, if we were to graph these, I can show that in another video, maybe part 2 video. So that's those measurements, and that's the sine, cosine, tangent of those. Let's do 45s. So we're going to add 45 degrees. We're going to do 135 degrees. We're going to do 225 degrees and 315 degrees. We'll add all 4 of these to our table. And in order to do this, we're going to need to do a squared plus b squared equals c squared. So this is a triangle. Notice if it's 45, I know that A, so a right triangle has A, B, and C. So here's our right triangle. We have A here, B is here, this height, and C is here. We know that C equals 1. We also know that A and B are the same thing. So it's going to be A squared plus another A squared equals 1. So it's safe to say that we have 2 A squareds is equal to 1. We can divide by 2. Divide by 2, we get A squared equals 1/2. And to figure out what A equals, A, we do the square root of both of these. So it'll be the square root of 1/2. In other words, the square root of 1 over the square root of 2. So we're coming up here now. Square root of 1 is 1. Square root of 2 is the square root of 2. Now we're not allowed to have a square root in the denominator. So what we need to do is multiply both of these by the square root of 2, by the square root of 2. I know these are probably super confusing. Square root of 2 times square root of 2 is 2. The number that multiplies by itself to make 2 times that same number makes, so we're going right up here, we get 2, and on the numerator we have square root of 2. So this is what A and B are. Well, A is its cosine, so that's square root of 2 over 2. And B is its sine, well, that's square root of 2 over 2. And its tangent, we divide those. So we'll have square root of 2 over 2 over square root of 2 over 2. Well, if you have the same on the numerator and denominator, notice that this is a term, this is a term. We have, it's like saying 5 divided by 5. Guess what? Just 1. Kind of neat. So if we know this height right here, this is square root of 2 over 2, comma, square root of 2 over 2. Now we know all 4 of these because this one is just negative cosine, same sine. So its sine is square root of 2 over 2. And we have negative square root of 2 over 2. For its cosine, we get -1. 225, they're both going to be negative. So negative square root of 2 over 2, negative square root of 2 over 2, and it's going to be +1 because negative divided by a negative. Last one, we have a negative sign because we're going down. And we have positive cosine because it's to the right, square root of 2 over 2, and we get -1 again because one of these is negative. How we doing? Having fun? All right, I'm going to get rid of all these, and we're going to do the 30-degree angles, which again, we only need a couple different numbers. Kind of like this one, we had the same pattern throughout this whole thing. So the last section here, we're going to do, let me change the color. We're going to go with, we'll start with our 30 degree. So 30 degrees, we need to figure out what these two numbers are. So this from here to here is 1/2, and we can see, we can measure it, it's 1/2. straight across. That's where it's at. So we're going to do 30, 60. We'll do 120, 150. We'll do 210, 240, 300, and 330. We'll do the sine, the cosine, and the tangent. All right, getting all our lines here. So from here to here is 1/2. Because this is, again, it's 1. So it's 1/2, and that's where 30 degrees hits. It hits at 1/2 is our sine. So at 30, our sine is 1/2. Notice at 60, our cosine is 1/2. So that's 1/2. Let's do all of our 1/2s really quick. Here, our sine, we don't know that, but we do know our cosine at 120 is 1/2. Our sine at 150 is 1/2. At 210, our sine is negative 1/2. At 240, our cosine is negative 1/2. At 300, our cosine is 1/2. I think I need to fix one of mine up above. So our cosine is 1/2. And at 330, we have a sine of negative 1/2. So I should have 4 positives and 4 negatives. I think I forgot that 120 cosine is negative 1/2. Now, we need to do our Pythagorean theorem again, our a squared plus b squared equals c squared, to figure out what our other side length is going to be. So we'll do that here. We've got a squared plus b squared equals c squared. So looking at this, we'll look at 30. Our a is here. Our b is going to be here. So we have a squared plus 1/2 squared equals 1 squared. Because c is our longest side, here's our right angle. So a squared plus 1/2 times 1/2 is 1/4 equals 1. We'll subtract 1/4 minus 1/4. We get a squared equals 1 minus 1/4 is 3/4. We'll do the square root of both sides. So that's a equals the square root of 3 over the square root of 4. Square root of 4 is 2. So square root of 3 over 2. That's going to be a simplified reduced form of what we're going to put in all these extra boxes. And we'll do tangent later. So our cosine of 30 is square root of 3 over 2. Notice that square root of 3 over 2 is larger than 1/2. So we're looking for all the larger sides. So I know that at 60 degrees, my sine is square root of 3 over 2. At 120, my sine is square root of 3 over 2. At 150, if my cosine is a negative square root of 3 over 2. For 210, my cosine is negative square root of 3 over 2. At 240, my sine is negative square root of 3 over 2. At 300, my sine is negative square root of 3 over 2. And at 330, my cosine is positive square root of 3 over 2. Let's double check we got 4 negatives. 1, 2, 3, 4, and 4 positives. It looks good. Now for tangent, for all of our tangents, that is, you take your sine value and you divide it by your cosine. So sine divided by cosine. I'm not going to do all these because it'd take forever. But 1/2 divided by square root of 3 over 2. That's, we're going to do keep, change, flip. 1/2 times 2 over square root of 3. Diagonally, we can cancel the 2's. So we get 1 over square root of 3. But remember, we can't have a square root in the denominator. So we'll multiply by square root of 3. Multiply by square root of 3. We get square root of 3 on the numerator over 3 in the denominator. Square root of 3 times square root of 3 is 3. So we got square root of 3 over 3. Next one, we're going to have sine over cosine. We'll do the opposite of that. Inverse, square root of 3 over 2 divided by 1/2. So this is going to be square root of 3 over 2, change it, flip it, cancel, cancel. We just get square root of 3. All right, and we could keep going. We can do all these. But the next thing I want to do is I want to go to Desmos. This is going to be our part 2. So I think I can squeeze it in. I want to show you what these look like. So we're going to pull up on Desmos graphing. Now I want to graph y equals sine of x. So sine is how high something is. So notice that at 0, our sine, remember, our sine at 0 is 0. And at when we get to 90 degrees, or when we get to pi over 2, which pi over 2, that's the number pi divided by 2. That's at 1.57. So when we find the x is 1.57, let's see what happens. So 1.57, 1.57, comma 1. Look at that. So at 1.57, our line has a peak at a height of 1, because that's what pi over 2. In fact, let me just type in pi divided by 2. There it is exactly. Pi divided by 4, comma, over 4. What was our y? Let's go back and check. Pi over 4, we're at, what am I doing? That was that. That's the sine. So square root of 2 over 2. Let's write that in there. Comma. Square root. Not sure. Well, let's type it and round it. Square root of 2 divided by 2. You get 0.707. 707. So there's our spot. So if we graph y equals sine of x, for every value, so like, where's pi? Pi should be at 0. Pi, comma, 0. We have a sine of 0. And when we get all the way back to pi, 2 pi, sine is also 0. So this is the height as we go around our circle. It gets higher, then it gets back to 0, then it gets lower, then it goes back to 0. And here we have it. Here, starting here, going around in a circle, starts at 0, gets higher, hits a peak, gets lower, hits 0, goes down, hits a trough, a bottom peak, like an upside down peak, and then gets back to 0. And it keeps going because we can keep going around the circle over and over and over again. So it's going to go up to our peak at pi over 2, down to pi, hits the bottom at 3 pi over 2, hits back at 2 pi, keeps going, 5 pi over 2, 3 pi. We have all these spots. And we can also see at cosine of x, it's going to be very much like this, except shifted just a little bit. Cosine of x, when we start at 0, our cosine is already at 1. And notice our x value on this graph, the left to right, starts all the way at positive 1. And then after we go full pi, we're back to 0, or we're at negative 1. So when we get to pi over 2, our x value should hit 0. So we start at 0. At pi over 2, we're at 0. Start at 1. At pi over 2, we're at 0. At pi, we're at negative 1. And we keep going. We keep going. We keep going around the circle. Never ending. Okay? And the last one, where we had undefined things, kind of goofy. Y equals tangent of x. We notice we have these crazy looking lines. And I want you to see that at x equals equals pi over 2. Pi over 2, notice this line, this blue line I just typed. Our red line gets closer and closer and closer and closer and closer to it, but it never touches it because it is impossible to divide by 0. And when we did tangent of pi over 2, we had to divide by 0, and that is impossible. So at tangent of 0, it was 0. At tangent of pi, it was 0. Pi over 6, I think, was square root of 3 over 2, which was about 5, or square root of 3 over 3, I think is what it was. So we tried that one. We also did divided pi over 3, and we got the square root of 3, 1.732. And that is how the unit circle works. You literally only use 3 different numbers over and over and over and over again. Those numbers are 1/2, square root of 3 over 2, and these two go together. Those are with all of your 30-degree angles. And it works with our 90s as well. You just reduce and simplify. So that's with all of these. And then the other numbers are positive and negative square root of 2 over 2, and those are for all our multiples of 45. And we have positive and negative square root of 2's over 2. And then for tangent, you just got to do some algebra, do some keep, change, flip, division, and you get the value for tangent. That's what all those buttons mean on your calculator.